So welcome Pradeepthi ma'am.
Thank you so much, ma'am. So, hope everyone has a basic idea on RNN, right? So, do you have any idea on RNN, recurrent neural networks, or LSTM? Can I get? Do you have any idea on RNN? So, can you please tell me? Do you have any idea on RNN, recurrent neural networks?
Yes, madam.
Yes. So hope that was a theoretical session which went in the morning session, right? So in continuation to it, I'm just gonna showcase you how do you create a model for RNN. So usually if you take any deep learning algorithm, whether it is convolution neural networks or artificial neural networks or natural language processing or anything, the previous data is not at all dependent on the present data. So for suppose, let's take a scenario where I would like to classify the animals. All right. So while classifying the animals, I have just trained a few images on cats, dogs, horses, something like that. Now first, I gave a horse image to predict for testing so that it gave me the prediction as horse. Now, next time I give another image, cat. Okay. In this scenario, there is nowhere any sort of connection between previous data or the present data. So the horse image which it predicted previously is not dependent on the present image, that is cat. But for RNN, this is purely considered as a recurrent neural network. That means the scenario will be in the form of recurrent series. All right. So first suppose let's take some sort of examples in RNN, like current price prediction of a building. All right. So first suppose the your current prediction, yeah, the current in the sense like the power prediction. So if you take this month, you will get power bill. Next month, you will get power bill. Next month, you will get power bill. So there is some sort of continuous series of generating a power bill. So in such kind of cases, in such kind of scenarios, if you implement this recurrent neural networks, then it will be easy for you to predict the future current price. So here the input as well as the output will be same. Input as well as output will be same. So for example, it's current price prediction. The current measured will be the input and the current measured will be the output. So we have to make the data in such a way that this particular column will be considered as input as well as output. So today we will be dealing with stock price prediction, where I have taken a data set of Google. Let me showcase you the data set. So here I have two data sets. One is train data set, another is test data set. Let me open my train data set. So here I have dates. So this is March, 3rd, January. I have stock prices from January 2012 to, let me see what's the date here, December 2016, January 2012 to December 2016. So let's see. Oh, I'm sorry. Am I presenting the screen? I'm really sorry. So sorry, there was a technical glitch. My screen got stuck. Yeah. So now let's see what is the data set I have. So here I already told you I have taken a data set for stock price prediction, and you can see I have two data sets. One is for training and other is for testing, right? So so here is my Google data set. This is Google stock price prediction. Now here if you see, I have few columns like open price. What is the open price of that particular stock on that day? What is the highest price per that day, and what is the lowest price, and what is the closing price? All right. So if you are trying to build a model on artificial neural networks, then you have to consider all these things as inputs and volume as output. All open, high, low, close as inputs and volume as output. But now in this scenario, as we are working on recurrent neural networks, single column can be considered as input as well as output. So here open will be input, but open will be output as well. But how are we able to process this information is, so we will be taking some sort of strategy in it. So what we do is, here we will take 60 days open price as input and 61th day price as output. So for suppose we have 1 to 5 8 rows over here, let's suppose. So here what I want to do is 1 to 60 days as inputs. To this input I will consider 61th day as output. In the same way, 2 to 61 as inputs, and then 62nd one as output. So it will be Greek and Latin if I tell you in this way. So if you see the program, then you can understand it in a better way. So let me open the data. Let me open the program. So I hope it is visible. Is it visible?
Yes, ma'am.
Yes. So now, here I have imported 3 libraries. Hope you are aware of artificial neural networks. Like yesterday during natural language processing, you have added input layer, output layer, hidden layer, something like that, right? So please put, so we will use some concept from that today as well. All right. So now, first thing I would like to do is, so let me write all the steps of RNN. The first thing that I would like to do is import the libraries. Yes. Second thing is read the data set. Read the data set. Third one is select the column which you would like to consider. Now, fourth one is write a logic in such a way that you split the data into x underscore train and y underscore train, the training part from the selected column, and then convert the data into arrays, as well as sixth one is convert the data into LSTM compatible format. Seventh step is add LSTM layers. Eighth step is train LSTM model. Once that's done, ninth step is read the test data set. The next one is same thing, read the column, read the data set, and then read the column which you would like to select from the test. And 11th one is same, strategy or the logic to create x underscore test and y underscore test. So from train data set, you will get x train and y train data. And from a test data set, you will get X test and Y test. So once you do this, again convert the data into arrays, convert the data into LSTM compatible format. Next is test the data, then plot the data between test data and predicted data. So these are all the steps that we will be implementing in the code. So the first step is importing the libraries. So here we have imported 3 libraries. One is NumPy for mathematical calculations behind, Matplotlib for plotting the graph, and Pandas is for reading the data set and applying some sort of analysis on the data set. So I have first read my data set. So let me first execute all these things. So I've imported the libraries. Now I am reading my data set. So my dataset name is Google stock price underscore train.csv, and I'm using Spider IDE. So you can use PyCharm or you can use Python IDLE. Any IDLE is fine, but I am using Spider IDLE over here. All right. So I have read my data set. Now, if you see these files, you can see my data set has been not files here. You will have variable explorer. This is Spider. You can see my data set has been read. So if you open this data set, you can see my data set is read. Now, the next step is to select the column which you would like to consider. So here I would like to consider the open column. So if you see, the open column is in, this is considered as 0th index. This is considered as first index. So I want to grab first column value. So in Python, if you know about indexing of strings or indexing of lists, at the end, if you want to grab sixth element, you will give it as 7. If you want to grab 7th element, but you will be giving it as 8, right? In the same way, here also we need to grab the first column, but you have to give the range from 1 to 2, so that your first open column will be read. So dataset dot ilog of all rows comma 1:2. So I am reading my open column as my value. So if you see this, why I am putting this values is, if suppose you do not put this value, let me show you. Now, whenever I'm just running this code, now if you see here, the train set is in the form of data frame, and it has 1 to 8 rows and 1 column. Let's see what is it. So that is an open price, but the deep learning algorithms will want the data to be in the form of array format. So that's the reason I add dot values at the end. So if you add dot values at the end, that means you are converting the data into NumPy array. So let me execute this again. Now, if you see array, you can see now it became an array. All right. Now again, it also has 128 rows and 1 column. Now, what I am doing is, so here there is an extra step, which is min-max scalar. Why we are scaling the data? So for an instance, there will be some sort of outliers in the data set. So outliers could be like, for suppose we consider marks only. Okay. So the minimum marks a student can get is 0. The maximum marks a student can get is 100. But by mistake, the master or a teacher made it as minus 125 and 1000. So this is a wrong data. All right. Your data should be between 0 to 100, but your data is in minus 125 to 1000, right? So what I want to do is, if suppose there are some sort of data which are like this, then I would like to convert all those them into some particular range. So here we are using min max scalar. Min max scalar will convert the range into -1 to 1. So in order to remove these outliers, we use min max scalar. So that's what we have done. So here we have used min max scalar, and if you see here the train set, it is 325, 331, something like that. Now let's run this code and see what happens. Sorry, this is F9. Now if you see here scaled data, the data set has been scaled. So 0 to 1, it got scaled. The min-max scalar gave the data to 0 to 1. So basically it was 325, 331, 321, but it scaled to a particular range so that the training will be very much easier. So now once this done, then the next step is to logic to create X-test and X-train and Y-train. So what is the logic that we have written? So first I have created two empty arrays. So here I have empty list, you can call it as X-train and Y-train. Now what I am doing is I am writing a logic in such a way that some data is getting appended to train and some data is getting appended to Y-train. So what is it? So first I am taking 60 to, the range is between 60 to 158. Now let's write this logic. So here let's take only this one. So I is 60, right? So 60 minus 60 is to 60 comma 0. So this is nothing but rows and this is nothing but columns. So in the 0th column, I would like to grab the rows from 0 is to 60 comma columns. So the rows are from 0 is to 60 and 0. So this is a first iteration. So in the first iteration, x underscore train will have data from 0 to 59 rows. 0 to 59 rows. So that means now how it happens is, so here x underscore train of 0 will have 60 values like day 0, day 1, day 2, day 3, day 4, and so on up to day 64, day 50, 59, right? This is for the first iteration. This is for the first iteration. Now in y, so if you take I comma 0, I is nothing but 60 comma 0 is nothing but the column. So again I'm telling, this is first one is row, the second one is column. In the 0th column I am considering I. Here I is 60th. So now for the first iteration, y underscore train of 0 became day 60. All right. Now the next iteration, for the next iteration it becomes 61 is 61 minus 60 is to 61. Now 1 is to 61. So in the x, so let's say this is x train, x train of 0, and now x underscore second iteration train of 1 will be day 1, day 2, and so on up to day 60. Then y underscore train will become y underscore train of 1 will become day 61. So every 60 days becomes input, and every 59 every 60 days becomes input, and 61st day becomes output. So after all the iterations, what happens is a new data set will be created. A new data set will be created in this way. Day 61 and so on up to day something up to, so day 2, day 2, day 3, day 4, day 5 up to day 61 to day 62 will be y. So like that 60 inputs will be there for each iteration. So now let's execute this. Let's see whether the same thing is happening or not. So now you will have 60 inputs and 1 output. So now let's execute this. F9. So it will take few seconds for that to get stored. So now you can see. Now let's see. Let's convert that into arrays. Now if you see, X train has 1198 rows with 60 columns. So 0, 1, 2, 3. You can see, right? You can see this, right? So 60, 60, 60 days became inputs, right? So this is how we will be converting one column into X train and Y train. It's our wish whether you would like to consider 10 days or 30 days or 40 days. Based on your wish, you can consider the days. If you want to use it for 1 week prediction, then you give it as 7. If you want it for 10 days prediction, you give it as 10. So based on your feasibility and all, you can split the data into X train and Y train. So once this is done, if you see the dimensions, it is having only 2 dimensions. That means rows and columns. But LSTM will accept only 3 dimensions. So that's the reason what I'm doing is I'm reshaping my X train into 3 columns. So here 3 columns is nothing but I'm just adding comma 1 and in the end. The rows and columns I'm putting the same, but I'm ending 1. So in order to convert into 3 dimensions or 4 dimensions, this should be the product of 2 dimensions. Let's suppose I'm converting 1 dimension to 2 dimensions, and in 1 dimension I have 10 elements. All right. Now I can convert this into 2 dimensions in different ways. One is like I add 5, 2, reshape of 5, 2, or 2, 5. So the middle one should be the multiple of 10. So here I'm using 2, 5 and 5, 2, which are multiples of 10. Now if I want to add another dimension to this, so 5 into 2 is 10. So even though if you want to add 3 dimensions, the multiples 2, 5, 1, if you multiply these 3, that should be 10 itself. So now here also the same thing. So this should be the multiples of two dimensions 1198 comma 60. So that's the reason I've taken 1198 comma 60 comma 1. So now let me run it. Now your data is run. Now let's see the shape. Now you can see it is 3 dimensions. So before it was 2 dimensions, but now it is 3 dimensions. Now my train data is ready. And let's see my X train and Y train also. I've shown you that, right? Again, I'll show you. Where is my X train? So you can see this is my Y train. This is less. X train. Sorry, I have to put it as 6. So this is you're unable to see the format properly. Let me show you with the print statement, then you can understand. Print of X underscore train. So you can see 3 dimensions with 60 inputs over there, right? Now let's train the algorithm. First, I am adding all the layers. So here I'm adding dense layers. So yesterday you have added input, output, and hidden layers, right? So in the same way, you're adding a dense layer, and also you are initializing the model as sequential. Now let's run this. Let's run this. And you're also adding LSTM layers. So now I am adding, so here I am adding 4 LSTM layers. So in LSTM layers, while adding, you should give how many number of neurons that you should have in your neural networks. So here I'm giving my units as 50. It's a random number. You can give any number based on your wish. So here I'm giving it as 50, and input shape is nothing but what is the shape of the input that you would like to give. And here I'm giving my shape as 1198 comma 60. So X underscore train dot shape of 1 comma 1. So that means I'll be giving only these 2 parameters, 1198 comma 60. That means I'm giving only 60 in, I'm telling that it is having only 60 inputs. And here I am giving my return sequence is equal to true. Whenever you write return sequence is equal to true, that means you are adding an other hidden or other LSTM layer. And again you're adding a dropout layer. So this dropout layer will also take care of some sort of extra values that will be added onto the model. So whenever there are a few extra values to the model, whenever you add some extra models to the model, it will check whether they are proper values or not. If suppose those are not proper values, this will drop those unnecessary values. In the same way, I'm adding a second LSTM layer. Again, I'm giving units as 50. and return sequence is equal to true. Return sequence is equal to true is nothing but it means I am adding another LSTM layer. Model.add LSTM layer, the third layer I'm adding, and here also I've written as sequence is equal to true. That means I am adding another LSTM layer. At the end, I stopped adding my layer. So that's the reason I didn't put my return underscore sequences is equal to true. So once this is done, I am adding the output layer. As the output is only one, I am adding the units as one only. So 4 layers, each layer has 50 neurons, and at the end I have only one output, which is one neuron giving you the open price. Now let's compile the model. Once the model is compiled, I hope everyone is following the explanation. Once the model is compiled, then I'll be fitting the model, and here I'm using my batch size is equal to 32 and the epoch as 1. So RNN will take so much of time to get trained, so that's the reason I'm giving it as 1. You should either give 1000 or 2000 or 3000. That means your model should be getting trained in such a way that it approximately gives the correct values. All right. So right now I'm using only one epoch, but you can use many epochs. So 500 or 900 or 1000. So let me run the code. So it's taking time to run the code. My training is done. So you can see my step is done. Train the LSTM model. As we have only half an hour, I'm explaining you the code. So I'll just share the code to you. You can execute in your systems. I'll also share the data set. So yes, my training is done. Now the next one is here. You should have 4 values. One is train, X train and Y train. And again you have X test and Y test. So for that you have to read the test data set. Now let's read the test data set. Data set is equal to PD underscore CSV. I've read the data set, and now I am reading the open price from the red data set. So because open price is what we are considering, right? Now here if you see the test data set, you can see there are only 21 rows. You can see there are only 21 rows. So the main criteria for X train and X test is, for suppose X train has, these are rows. Rows can be anything, comma, columns. This is the shape that should X train or X test or X Y train or Y test should have. X train, if suppose X train has some rows like 1198 comma 60. All right. And Y train has 1198 comma 0, that is one column, right? Y test should have, it could be any number of rows, but 60 columns should be there for sure. 60 columns should be there for sure, because in X train we are training the machine with 60 inputs. So you have to test the, this is X test, I'm sorry. You have to test the model with 60 inputs only. In the same way, Y train also should have any number of rows, but only one column. So, but if you see my test data set, There are only 21 rows. In train data set, I have 1 to 58 rows. So I have created a logic in this way. I've created a logic in this way, like 60 comma 1 to 58, and I have appended my x train and y test. But in 21 rows, can I get 60 rows together? No, I don't. So for that, what I am doing is, first of all, I am creating a total data set. So here what I am doing is, I am concatenating my test data set open and train data set open. So for suppose in a train data set, I have 1 to 58 values. And in a test data set, I have 20 values. Now my total data set will become 1 to 7, 8. 1 to 7, 8, because I am adding both the open test in the total data set. If you see, now the total data set is open and test F9. Now it will have 1 to 58. Just open your variable explorer. Now see data set underscore total. If you see, there are 1 to 7, 8 rows. So we are concatenating both the train data set as well as test data set open. Okay. So from this, I am writing a logic in such a way that my inputs data set will have 80 rows. Input data set has 80 rows. Instead of 21, I'll have 80 rows. So for that, what we are doing is, I am writing a logic which says data set of total, data total is equal to length of data set total. Length of data set total is nothing but 1278 minus 1278 minus length of data set underscore test. So the data set underscore test has only 20 rows. 20 minus 60 is to 60 is to dot values. Dot values. Now if you see, 1278 minus 20 is 1258. 1258 minus 60 is becomes 1198 is to. So data set of data set underscore total of 1198 is 2. This is what the value is. Now let's see data set underscore total. So in this data set underscore total, I am considering the rows from 1198. So if you see, so from where is this one? Yeah, so here I have 1198. So from here, from 779 to last, I am taking it as inputs. So in order to get that 60 columns output, I am increasing my test data from 20 rows to 80 rows. So whenever you apply this functionality, then your test data will have 80 rows. So once the test data is having 80 rows, then you can apply the same logic that I have implemented above. So here I'm taking X test. So now the same thing is happening here again. So I am taking 60 comma 80, and each and every 60 columns I am considering as the test values. Now in the same way we are converting the data into LSTM compatible values. Once this is done, then I am predicting the stock price with X test. So now my X test is ready. Now my X test is ready. Now I will be using that X test for training the model. Just execute this. Then now let's plot the data between real stock price as well as predicted stock price. So I've tested my model, and then let's plot my graph. So if you see in the plots, you can see there is a way difference between red one is the main values, blue one is our predicted values. So we have to increase this epochs number 900 or 1000. You can either put 900 or 1000, so that this and this will become equal. So this is how we will be training the time series data with RNN. All right, so this is how we'll be training the data. Hope everyone got at least a basic idea of how to train a RNN model. So you have to consider only one column. So hope this is how you will be training the model. So if you have any doubts, you can ask me. So if you don't have any doubts, then I'll be ending the session. So It's fine. If you don't have any doubts, I'll be ending the session.
So, Pradipti ma'am, that's all from your side?
Yes, yes, ma'am. That's all from my side.
Okay.
Actually,
So, participants, you may please put the queries in the chat box if you are having any query, or you may unmute yourself. I think no one query, ma'am, from the participants.
yeah, yes, ma'am.
So, thank you, Pradipti ma'am. Thank you
Thank
for the wonderful session. Thanks one again.
Yeah, thanks, ma'am. Thanks a lot.